Hello, welcome back to Math with Patrick. It's May 3rd, and we have problem number 123 to solve from this Daily Epsilon calendar. And we need to show why this x in the exponent here should be a 3 for today. So I'm noticing I have some kind of exponential equation, right? Our variable is hiding in the exponent here. And usually a good strategy for these problems is to find like a common base. Like here my base is 4, here my base is 2, and this is just the number 32. And none of these are the same base. Like I'm thinking I could make them all turn into a 2 and it won't be too hard to do that. So I'm just going to rewrite the problem as is, and then I'm going to try to figure out how I can replace some of those bases with 2's instead of the 4 and the 32. Well, 4 is just 2 times 2, or 2 squared. So I could rewrite it like, oop, that Quill just hopped in my lap and kind of messed with my handwriting there. So 4 is 2 squared. That's still to the power of x. And then to get 32, I could do 2 times 2 is 4, 8, 16, and then 32. So this is just 2 to the power of 5. And then I'll just rewrite 2 to the power of x plus 2 as is. And this is all still equal to 0. And I can't really express 0 as a power of 2. Like I could try, but 2 to the power of 0 is 1. 2 to the power of anything positive is going to be greater than 1. And then 2 to the power of anything negative will just kind of be between 1 and 0. So I can't really do anything with that 0, but maybe I could like add one of these terms over to the other side to balance my equation. So I guess maybe I'll do that. Maybe it'll be nice to like add this 2 to the power of 5 to the other side. So I'll do just that. And then I want to like also simplify what's going on here. Anytime you have stacked exponents, like something to the power of another thing and then to the power of another thing, like basically this scenario right here, you're allowed to multiply the exponents together. So I'll do 2 to the power of 2x minus 2 to the power of x plus 2, and this should all be equal to 2 to the power of 5. All right. I found a common base, but I want to shove these together, I think. Just because, like, if I can get 2 to the power of something equals 2 to the power of something, I can just compare the exponents to each other. But having a copy of this to like both of these over here makes it a little bit hard. I think maybe I could do some factoring. I'm not sure. I mean, I could try, right? If I factor out a 2 to the power of x plus 2, I would be left with a 1 right here. And then 2 to the power of, what's this going to be? Essentially, it'll be 2x minus x plus 2. So I guess if I distribute this negative sign, I'll get x minus 2 for this exponent. And still, supposedly, this is all equal to 2 to the power of 5. Not quite seeing it here. Although, I guess if this right here is equal to some power of 2, then that must mean that I have a lot of 2's being multiplied here, but then I would have to have some kind of power of 2 here also. Like maybe it could be the number 1, maybe it could be the number 2, or 4, or 8. And so I think if I actually go on that, maybe not tangent, but if I try to like figure something out with that, I might get an answer here. So like this has to be some power of 2. And then if I try plugging in some numbers, like if I try plugging in like a -1 here, I'm going to get some kind of fraction. And so the first number that could maybe make sense would be plugging in a 2 here. But I do get 2 to the power of 0 minus 1. Oh, and that's 0. Yeah, and that's a little bit of an issue. I can't do 2 to some power. Maybe I'll make that b look a bit more like a b. And I know that I can't get a 0 out of that. So maybe I could try when x is 3, perhaps. then I do get 2 to the power of 1. And then minus 1, I do get a 1. So this could work. It's a potential answer there, or like a potential exponent or value for x. And then if I try maybe a 4 here, I'll get 2 to the power of 2, which is 4. And then 4 minus 1 is 3. Okay. And so any other number I try right here, I'm going to get a power of 2, but 1 less than that. And there really isn't another power of 2, and then you subtract a 1. Like, you're not going to get another power of 2 unless you have that scenario where x was 3. And I think that basically just proves it. So I could sub in x equals 3. That's the only number that produces a power of 2 right here, and hopefully it will make the rest of the equation line up. So when x is 3, I'll put a 3 here and a 3 there, and I'll fill in the rest. Let's see, 2 to the power of 3 plus 2 times 2 to the power of 3 minus 2 minus 1. Is this equal to 2 to the power of 5? And then we just saw earlier that this number is just a 1, and then 2 to the power of 3 plus 2 is 2 to the power of 5. So nice, that does check out, and so that does mean that x is equal to 3 for today. Just to be sure, we could also graph it today. So I'm just going to type in the problem and then see what kind of thing we get. Looks like it's kind of like an exponential function where we have some horizontal asymptote and then it like rockets upwards really quickly. There is this like interesting feature down here that other exponential functions don't have, so that's kind of neat. But if I'm looking around, there's really only one spot where I'm going to get a value of 0, and it's right here when x is equal to 3. So that's just more confidence that x equals 3 is the answer, and it's the only answer for today. So guess I'm all done. Thanks for solving this problem with me, and I'll see you tomorrow. All right, bye-bye.